Hey there, TouchDesigner developers. DiLaura here with the Interactive and Immersive HQ. In this video, we're going to take some loose inspiration from the intro sequence of the TV show The Last of Us and work with the L-System SOP in TouchDesigner to create this organic growth type effect. Now, the L-System SOP in my book is a highly underrated and very interesting operator that can generate all kinds of amazing organic growth style geometry like we see here, along with a variety of interesting geometric patterns as well. Here is a quick look at the Last of Us TV show's intro, which incorporates this really interesting organic growth of this fungus, which is a part of the TV show's plot. So obviously the effect that we're creating today is not going to be quite as sophisticated as the effect that was created for this, but we thought we would use this as a jumping off point to look at how we can start to approach creating organic growth within TouchDesigner, and specifically working with the L-System SOP to create that sort of geometry. So we're going to start off with a blank network by adding the L-System SOP. If you've never worked with the L-System SOP before, it allows you to create this really intricate organic growth by defining in code a premise, which is kind of like an initial state, and then a series of rules that dictate how that growth will actually occur over a period of a specified number of generations. So if we take a look at this example that is loaded up when you add the operator to your network, and we pull back the number of generations via this parameter over here, you can see that when we start at generation 0, we can see what is called the premise. Again, this kind of initial state, which is basically a straight line. And so the straight line, again, is just the starting point. And it's really only because of the rules which are defined below, this A equals and B equals, different lines of code here, that over the next couple of generations, we start to first take that initial sort of stem and split that into 3 branches. And then from there, those 3 branches can be split into 3 branches each. And if we keep increasing, so on and so forth. So what's really powerful about this system is that we can take these rules and we can create this sort of exponential kind of growth where generation has the same function applied to it over and over and over again. So what that means is, as in this case, if we take the initial stem, we can keep applying this operation of splitting off into branches until we are left with maybe something like this, which is a very robust kind of tree-like structure. So it's very powerful, and we're not going to dive fully into all of the different functions that it has because there are a ton of them, but we are going to copy and paste some code into this and just briefly look at what the functions within that code, actually contain and how they are generating the effect that we're going to be working with today. So before I paste in the code, I'm going to take the number of generations back to 0 for a moment, just so we don't cause any unnecessary kind of overload of our system here. And then I'm going to paste the code in. So in your situation, you'll have to click on a link in the description below and grab the text that is going to be linked there and paste it into the L-System 1 rules dat. Once you've done that, we'll click off of that operator, and that will have rewritten in the operator the rules that it is using. So you can see that this code looks a little bit different than what we had previously. We have a lot more lines of code, and if we increase the number of generations, we'll see that the outcome is also very different. So we start off with like a branching structure, but the branches, as we can see, start moving in a very different kind of orientation, a little bit more random and in all directions rather than following a kind of traditional tree structure. And eventually we'll take this number of generations up to 14 and end up with this very kind of crazy complex structure that is intended to kind of look like the fungal growth that we see in the beginning of the Last of Us intro. So let's have a look now at the functions found within this code. So I've put together a handy little guide for any of us who are not familiar with L-systems or working with this operator. We tend to conceptualize the sort of underlying functionality of the L-system in terms of the movement of a turtle. So you'll see often turtle commands or turtle operations referenced. And when we're talking about this turtle, the idea is that the L-system essentially can be thought of as if we have this turtle that we can send commands to kind of dictate how it moves and thus sort of creates these structures. So when we see any of these characters over here on the left, those are going to allow us to control the turtle's movement. The capital F is probably the most common command or operation that you'll see, and this is going to tell our turtle operator to move forward one step and draw a line. So anytime that we're in this initial state, like we saw here at generation 0, for example, where we have just this single line drawn upward, that is a result of our premise, remember, that's our initial state, having that F in it. Likewise, we've got some other commands here that can orient the turtle differently. So we have, by adding a plus or a minus into that set of rules, we can tell the turtle to move left or move right. Now, what I want to specify here is that when we see a plus or a minus, that doesn't dictate any forward movement by itself. That's just telling the turtle to move, but we then need to add the F after that plus or minus to actually make the move happen in that new direction. You can see an example here. So we've got F, which just moves us from the starting point one step forward. Let me just increase the size here a little bit. So F takes us from the starting point one step forward, and then we can't actually move at our new angle in the rightward direction in this second example until we actually put this second F here. So we've got F plus F would mean move one step forward and then turn to the right and move another step in that direction. Now, in the case of the L-System SOP, the angle that we're turning left or right by is by default going to be defined by a parameter in that operator. Next up, we've got this little single quote here, and this is used to increment the color index U, which might not mean a lot to you at the moment, but essentially it is in this code so that when we get to the point of rendering, if we choose to use like a line material or something like that, we aren't merely left with just a solid color kind of applied to the whole organic structure that we've created. We can also work with things like ramps to add like a gradient across that structure. So again, that's used for adding color later on. Next up, we have brackets. So open and close brackets, anytime that we see these are going to tell us that we can or that we are currently in the process of creating something called a branch. So if we look at the example here to the right, this can help explain things. Essentially, the first two steps here look identical to what we have here. So we start off, we move one step forward, and then in our second step, we move one step forward, and then we turn to the right and move another step forward in that new rightward direction. The difference here is that this step to the right is found within brackets, meaning that it is has been defined as a branch. And that means that we can add outside of those brackets additional, let's say F, we could do plus F, etc. We can add additional operations or commands outside of the brackets. And what will happen is after this branch has been completed up here in the right, we'll return to the last place that we were prior to this branch being created. We're essentially popping ourselves back to, again, the point at which we branched off from the main sort of stem. And then we can continue moving forward in that original direction with that original orientation. So it's with these brackets, again, that we can branch off from that main stem and then be able to return to it. Next up, we have a tilde and then a decimal or integer value inside of parentheses. Anytime that we see this, what we will know is that we're adding some level of random rotation to our system. So previously, we've just seen some sort of straight movement in 2 dimensions. But when we use this command here, we can say, let's say we had 10 inside of these parentheses here. That will allow us to add a random amount of rotation in any one of the XYZ axes up to 10 degrees. So we use that in a number of places in our code so that our branching system starts to move and sort of bend in 3 dimensions instead of just being a flat planar kind of construction. So lastly, we've got the colon and then a decimal or integer value. This is a way for us to define the probability that a rule will actually be used. So with this probability function, we can actually define multiple completely different rules. And then by dictating a sort of percentage value, automatically have our system randomly kind of select based on this percentage weighting which one of the rules will be chosen at each sort of step in the process. So this allows us to, again, define very different kinds of movement for our turtle, and then have varying levels of chance that each one of those paths will actually be chosen. So all in all, although it looks complicated, we really are just sort of choosing from a variety of different options here to either move forward, maybe turn a little bit left or right, and then also at the same time choose the ability to make a branch with, again, varying levels of rightward or leftward turning being applied. And then, of course, a little bit of random rotation added into the mix. So that is what allows us over these number of generations to randomly choose from those different rules and eventually build this kind of branching structure in all different directions. So I'm going to set the generations here to 14. That gave me a suitably complex enough kind of construction for this example. And I also want to point out that, we're talking a lot about these random choices, these random functions that are being applied within this code. We also can adjust over here. You can see a random seed value, which will allow us to, regenerate those random values and choose a different seed for that random functionality. That can be used to add a little bit of variety to the final result of your system. For my example, if you want to make it exactly the same as what we saw at the intro of the video, we're going to set that random seed at 0. Now, the other thing that we can do that's pretty cool with the L-System SOP is to set up the output rather than drawing these lines to actually generate a 3-dimensional tube shape that, again, follows the kind of path of this organic structure that we've created. And that can be helpful, as in this case, when you want to create a more 3-dimensional structure with it. Now, that is not to say, of course, that what we have already isn't being generated in 3 dimensions. It just means that we can control things like the kind of thickness of the lines and other things like kind of the curvature of the turns that we're going to be generating, etc. So it's another way basically of giving us options in terms of rendering. We can also get things, of course, when we're working in 3D like shadows and lighting that would not be possible with a simple line material. So anyway, to engage or to turn on the ability to draw a tube rather than a line, we have to change from the type here of skeleton to tube, which will give us this kind of flat result at the moment. We'll kind of correct for that later. And then let's head over to the tube page. I'm going to make some changes here. to make the resolution of the tubes that we've drawn look a little bit different. I'm going to turn on wireframe for a second here just to walk us through this step. So I've done that by moving my mouse over the active viewer of our L-System SOP, and you can see, and then by hitting the W key in that active viewer, you can see immediately that the tubes that we're drawing here really are kind of low poly count. They are triangles, basically, with a number of kind of divisions down the tube itself. We can increase that sort of resolution, quote unquote, by changing the number of rows and columns. So I'm going to set the number of rows here to 16, which will give us an almost circular cross section. I can then also increase the number of columns to 10, which will increase the number of divisions along that tube shape, which will give us, instead of those sort of harsh turns, we get a little bit more curvature to the turns that we're generating. So that will help make things look a little bit less low poly, kind of computer graphics-esque, and maybe a little bit more organic. The other things I want to do on this page are to set the thickness value here to 0.135, which will increase the thickness a bit. And then I'm also going to apply the tube texture coordinates. Now, because we're drawing this, or we're going to be rendering this as a tube, and wanting to texture that to add a kind of colorful animation to it, we're going to use this function here to give us texture coordinates to make that possible. The last thing I'm going to do on this page is to set the vertical increment to 0.05. And that will help with the kind of application of the texture on this shape once we get to that point. Now, we have some other things we need to change on the values page. So I'm going to head there next. This is where we can define some of the constants, or the values that we looked at in that reference sheet, whether that's the amount of sort of distance that we're covering every time we see that F line in our code, or the angle that we're turning left and right. I'm going to set the step size here, which is the distance that our F line of code is going to take us forward, to 0.2. And that's going to have the effect of increasing the scale of this geometry a little bit. So it's going to take and kind of separate out the tubes we've generated a little bit. I'm also going to turn off at this point the wireframe so we can see what we've got. So I'm going to mouse over this active viewer and then hit W, and here's what we're left with. The next thing I'm going to do is to adjust the angle parameter, and I'm going to set that from this value of 28 to 15 degrees, which will dramatically change our structure. And hopefully now you can see the kind of fungal growth aspect of this. So again, the angle parameter here is what dictates, whenever we see the plus or minus sign in the code, how many degrees we're turning left or right, and thus can really dramatically change what the overall structure looks like. So that's actually it for our L-System SOP itself. Of course, feel free to start playing around with the code here to customize things yourself, and I would highly recommend checking out the L-System SOP page in the derivative wiki, because it has a huge number of operators that can be applied to our turtle's movement, which we can see here under turtle operators. There's a bunch that we didn't even cover in this short section of our video, along with some other really useful functions as well. So a ton of great stuff in here that can be added into the mix to get your L-Systems complexity even higher than what we're at right now. The next step that I'm going to take in this setup of our SOP network is to add an attribute create SOP. And I'm going to use this to compute normals, because I want to correctly be able to texture and kind of shade the shape that we've created here and light it as well. So I'm going to compute normals by adding the attribute create SOP and turning on the compute normals toggle switch. That's our last step in the SOP network. We're now going to take this into the geometry comp and start our rendering pipeline. So next up, we're going to add a null to the attribute create, and then we're going to right-click on the output of the null, head to the comp page, and grab the geometry component. Next up, we're going to need to add a material, our camera, lighting, and a render top. So I'm going to start off by adding my material, which is going to be a Fong material in this case. And then I want to assign this to the geo comp. So I'm going to click and drag it onto geo1 and hit parameter material. Then I'm going to add in a camera comp and a light comp so that we can render this. And I ended up, we'll come back and adjust the camera comp to the view that I had at the beginning. I achieved that basically by interacting with the viewer itself. But let's at least get the render top into the mix here so we can see the output from that camera. So here it is. And now we're going to just enter in those values to get the camera in that position that we saw at the beginning of the video. So these are, again, kind of arbitrary because I was just moving the camera around manually. But my translate values were -2.7, -0.2, and then 0.9. So that's -2.7 in the X, -0.2 in the Y, and 0.9 in the Z direction. Then we're going to head down to rotate, where I had -35 and a half, 35.5 degrees in the X direction, 73 degrees in the Y direction, and 0 degrees in the Z direction. The last thing we're going to have to do is adjust the pivot in order to actually orient us in the correct location towards our shape. So my pivot values were 2.7 in the X, -0.1 in the Y, and finally -3.7 in Z. And you'll see that pulls the camera right up to the position that we were at in the beginning of the video. So to add more realism to the shadows and shading of our shapes, I ended up adding an SSAO top after the render top. And in the parameters here, I just set the SSAO pass resolution to full. Finally, I added a bloom top. And then I slightly adjusted the bloom threshold parameter here to 0.0325, which doesn't come into play a whole lot yet, but when we add color into the mix in a moment, that will kind of impact that more. We can then add a final null here, and that's it for our top texturing. Now we're going to focus on adding the color animation that was showcased at the beginning of the video. I'm going to start off with a ramp top to be able to generate a gradient, which we'll use again to apply color to our L system. In this ramp top, I'm going to make the gradient here start off at a kind of bright red color and then fade to a black color. So on my left color keyframe here, I'm going to click on that once, and then I can leave the hue basically at this default, or at least where it is for me, but make sure to drag the hue to the red area, which would be either around 0 or 360. And then we're going to increase the value and the saturation so that we see red on the left side. I'm going to click on the rightmost color keyframe next and turn my saturation up, and then decrease the value to 0 so that I end up with black on the right. The other thing that I want to do actually is have this right side not only be black, but have some transparency. So I'm going to decrease the alpha for this rightmost color keyframe as well. So we've got red here, and then a transparent right side of this gradient. I'm also going to go ahead and add in a second color keyframe kind of over here on the right, and move this to the center. And what I'm going to do with this one, again, like I did with this rightmost color keyframe, I'm going to reduce the value in the alpha to 0. So I'm kind of moving this gradient shift from full red to transparency a little bit further in the left direction. That's it for my color keyframes. So I'm going to move on and set my type here to vertical. So my goal here is to orient this texture in such a way that it will make the L-System look as if it's growing sort of from its starting point. So we're going to have to do a little bit more work to make that possible, but that is kind of where things are headed. The other thing I'm going to do here is to set my extend left to hold. And that will mean when I start off adjusting my phase from 0 to, let's say, -1, we'll end up with full transparency. And conversely, when I move the phase to 1, we'll have a full red texture. So we can sort of create a transition between these two states. We're going to come back and add a chop reference again in a second for animating this parameter. The last thing I'm going to do is to turn on the dither switch, and then we can add some additional operators. So another aspect of the effect seen at the beginning is the reduction of saturation after a period of time. So meaning that the red color will shift to white after a period of time. And I accomplish that by using the HSV adjust top. This has a saturation multiplier slider, which if we move to the left will reduce our saturation to 0, leaving us with white anywhere that we had red initially. Again, that's going to be animated via some chops that we'll add in a second. And our last step here is actually to add a flip top. And this is needed because we want to, again, create the illusion of growth from the kind of starting point of the L-System outward. And the way that the texture essentially is applied, or kind of the coordinates, the UV coordinates are assigned to our L-System, we kind of have to start from the top and then animate the red sort of fade in downwards in order for it to animate in the correct direction. That is, from the starting point of the L-System growing outward rather than starting at the furthest extent and coming inward. So the flip is going to be used here, specifically the flip Y setting, again, to inverse the kind of default direction of the ramp. The final thing I'll do is to add a null, and this will be our color map. So I'll call that null color map. And then we'll work on adding a chop network to animate this. So I'm going to add a timer. And we're going to use a really cool function of the timer, which is the ability to actually create two simultaneous parallel timers that are running from the same operator, meaning that we can have two timers within the same operator that have completely different settings, but are both going to be started and running at the exact same time. So we can animate two different things at once. I've got my timer chop added, and I'm going to need a table dat in order to set that up. So I'm going to head to the dat page and grab a table dat. And then I need this to be a total of 2 columns wide and 3 rows. So I'm going to go to the fill page, and I'm going to set the fill type here to set size. I'm going to set the number of rows to 3, and then the number of columns here to 2. Then once I've got those settings changed, I'm going to come into this table dat. I'm going to click Viewer Active in the lower right and type in my titles for this table. So I've got length. My length parameters are going to be found in the first column, and delay parameters are going to be found in the second column. My first timer, which is going to control that transition from transparent to red, is going to be 20 seconds long and is going to have no delay applied to it. The next timer is going to be for the desaturation, so the transition from full saturation to no saturation. I want that to occur over 5 seconds, but I don't want it to start at the exact same time that I am doing this transition from transparent to red. I want to delay that transition, so I'm going to add a 15-second delay to that second timer, again, to wait for that to actually start. Now that I've got those changes made, I'm going to come back to my timer and head to the segments page. Here I can provide my table dat as a segments dat for this operator. So I'm going to click and drag this onto the segments dat parameter, and then I'm going to change the segment method from serial timers to parallel timers. Now you'll notice the number of channels that we've generated here has doubled, and we actually now have 2 timer fraction channels, which we'll use to animate the parameters in our ramp and HSV adjust operators. So I'm going to create an initial branch of this chop network to control the ramp, and then I'll copy and paste that and use it to adjust the HSV adjust operator. So I'm going to come back to the chop page in our op create dialog here, and I'm going to add a select chop. And this is going to be used to pull in this specific channel that I need. Now I'm going to add my operators first and then kind of come back and edit them. So I'm going to add, after the select, a math chop and then a null. And then that is going to be for the phase of the ramp. So I'm going to call this null phase. I'm going to copy box select by right-clicking and dragging, and copy all 3 of these operators by hitting Control-C and then Control-V to paste. So again, I have a second branch here that will be used for the HSV adjust. Here in my second null, I'm going to change this to null saturation so that I know this is going to be used to control my saturation parameter. Let's come back to this first branch and set things up for the ramp. So I'm going to go to the select chop first and grab the under the channel names parameter. I'm going to click the little rightward facing arrow and choose timer fraction 0. In the math chop, I'm going to change the range of this channel slightly. So this is going to, by default, go between 0 and 1 over the course of that 20-second timer. I need the initial state, the starting point where we're at right now, to be a little bit less than 0, because 0, as we can see here for this phase parameter, is going to leave a lot of this red gradient still visible. So in the math chop, I'm going to come to the range page and I'm going to set my to range here slightly differently. I need to have the initial state, that is the lower sort of boundary of this to range, to be even less than 0. So I'm going to try something like negative 0.4 in this to range, which means I'll start at a value of 0 or negative 0.4, excuse me, and then end at a value of 1. Let's go ahead and try that. So I've got those changes made here. I'm going to make a chop reference from null phase to ramp 1. So I'll click on the little star icon, viewer active switch, on the bottom right of the null phase chop. And then I'll click on my ramp top next to highlight it and have the parameters appear on the right. Then I'm going to mouse over the active viewer of null phase, left click and drag, and let go when I've reached my phase parameter. Then in the little dialog that pops up here, I'm going to choose chop reference. And you'll see that this minimum setting has mostly gotten rid of that red gradient. It's still appearing a little bit at the bottom, so we could even adjust this further, but I think for the purposes of what we're doing right now, this will be okay. Next up, let's go ahead and set up the HSV adjust. So again, I'm going to come to the select chop first and grab the actual channel that I need. I'm going to come to the channel names parameter and click the rightward facing arrow, bring up this drop down and choose timer fraction 1, which will be the output again of that second timer. Here in the math chop, we're going to actually just basically inverse the direction of the data that we have right now. So instead of our timer going from 0 to 1, we're going to start at a value of 1 and then have it transition to 0. We can do that on the range page. So again, we're going to use the toRange parameter. So we know that our incoming range is 0 to 1, so our from range is okay. But the toRange, I want to start at 1 and end at 0. So I'm going to change the first parameter there to 1 and the second to 0. Once I've made that change, I'm going to now make the chop reference from null saturation over to my HSV adjust. So again, I've clicked on my HSV adjust operator so that the parameters appear here. I'm going to activate the viewer of my null saturation chop by clicking on the little star icon in the lower right. And then I'll left click and drag on the active viewer over to the saturation multiplier parameter and let go. I'll choose chop reference. And with that, we should be all set. So what I'll do now is let's go ahead and start our timer and see if everything is working. So I'm going to come over to the timer chop and I will initialize it first and then hit start. So as we can see, our color will fade in over a period of 20 seconds. And at a certain point, we'll notice that our second timer starts running, and then it will fade the color from red to white. So that looks great. So all that's left to do now is to click on our Fong material, and we're going to drag null color map onto the color map parameter. And we also need to make a couple of additional changes to this Fong mat because we also want to be able to utilize the transparency in this ramp texture in that kind of initial state. So what I'm going to do is to set up on the common page, I'm going to turn the blending transparency switch on. With the color map assigned and the blending transparency switch on, we should be able to start the timer over again and actually see the color applied to our output. So let me actually go over here to, first of all, I want to point out I've clicked on the timer 1 operator and I'll look at my null operator at the end of my top network, excuse me. When I initialize, we should see that this is mostly transparent. And that little sort of whisper of our L-System, again, is because I didn't set my math range quite right. We could reduce that toRange parameter a little bit in order to remove this. But, for the purposes of this, it's okay. I'm going to initialize and then start the timer. And we should see the L-System start to grow over a period of 20 seconds. And you'll see as the transparency fades in, so does the red color. And then after the L-System is fully kind of filled in, it'll slowly transition from red to white. So that's it for our video today. I hope this has been a useful and fun look at how we can use the L-System SOP in TouchDesigner, as well as how we can use textures to add animation and create the illusion of growth with this L-System geometry. If you're looking to dive further into L-Systems, I'd highly recommend looking at the L-System SOP page in the derivative documentation, and especially looking, at the various commands and functionalities that are listed here that we didn't even get a chance to cover in this video. There's a ton of stuff available to really add some complexity to the geometry that you're creating. Another resource that's well worth looking at is the book that's referenced here called The Algorithmic Beauty of Plants. This is a fabulous resource that goes through all kinds of different different formulas, rules that can be used to create a ton of different geometric patterns, organic looking shapes, etc. And again, it'll really give you an idea of the possibilities for working with L-Systems. So with that said, I hope you've enjoyed putting this one together. Looking forward to seeing you in the next video. Thanks so much for watching.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and immersive content.